So we see about merging from feature branch to the main branch. Now there is something called a pull request. So before merging to the master branch or main branch, uh, the people can communicate with each other. But there's another option which is called a pull request. So if I made some changes in a feature branch, and here I can open pull request. So it is up to date right now. But here we can make a pull request with a description and name. So that will be sent to the owner of the owner of the repository to then if he wants to merge that change or not. Now, while making a pull request, there can be conflicts also. For example, in master branch, I make changes to a file, and also in a new branch, in a new feature branch, I make some changes. So while making a pull request, that will also create conflict. So for example, in this new branch, so we create a new branch and there we make some changes to this flowers file, and then I push those changes onto the new origin branch on GitHub. And then here we have this master branch. In the master branch, we go to this same file and we make some changes here from GitHub. So while we are on the new branch, so here we can make the request, but that will create conflicts because we will have to resolve the conflicts because there are changes from both the branches. We can, but still we can make the commit. We can still make the request, pull request. So then owner of repository will be able to resolve the request from here. So here we can see the pull request, and here we get an option to resolve the request. But we can also resolve the request uh, like we did previously in a code editor. So for that, first we switch to master, and first we will have to pull the changes that we made on the origin, and we pull those changes, and then we switch to the new and we merge master there. Now we see that conflicts arise. This conflict arises because of the changes in this file, and then this will open in our code editor. So for example, we made these changes from this new branch and this from the master branch. So we want to keep both of these like this, or whatever we want to keep, and then we add this file again and make the commit. So now the conflict is resolved. So now we switch back to the master again, and now we merge. We have this command no ff. Uh, this means that this will not do this in fast forward manner. So this will always create a new merge. So now this is merged. Now we push the master back on the GitHub. So these are the steps that we can use to resolve the conflicts by using pull request. So first we pull the changes, whatever we had in the master, and then we switch to the new branch, the feature branch, and there we resolve the conflicts, and then we switch back to the master branch, and then we merge. No, so we merge, uh, resolve the conflicts and merge in the new branch, and then we switch back to the master, and then we merge the new, and then push back to the origin. So this is how we can resolve the conflicts on pull request. Now here we can create some rules. These are called branch protection rules. For example, we have this rule that we select require a pull request before merging. So whenever there is a merge request, whenever we change some file in a particular branch that we have to select here, we select the default and target branch here. And we keep this enforcement status as active. So this rule will be enforced for this branch uh, to only merge, to only accept commits when we via pull request, when they will be transferred to a new branch, which is not the branch that we select here. So now we can create the rule here, and here in this branch, if we want to change something here, and we try to commit changes. So this tells that you can commit to master because it is a protected branch. Without this rule, we can just commit the change to the master branch. Now we will have to create a new branch for this commit and then use the pull request to then merge it to master. This is the branch protection rule. Now we have forking. So forking allows us to copy a complete repository on our GitHub. So we have this 2048 game. We have this repository, entire repository from this account. So here we have the option. Here we have the option to fork this entire repository on our system, on on our GitHub account. So we have forked this. So now here it will say that this is up to date with the original owner. Before we make some changes, so now after we fork this, we can make any changes to this repository, and we can clone this on our local machine and then push back any changes. Then we can open this on website. So we took a repository, public repository from GitHub, and we copy that complete copy and make our own changes. This has now become a repository. So we can do anything with this. So after forking from here, we have this URL to clone this. We create a new folder and we clone that repository here on a local machine. So we have this entire repository here now. So this is now a repository. We have all these files. Now we see on remote version, we see that this is our repository now. We have our account name. For example, now we make some changes to these files. We can make some changes and commit and then push back to the origin master. So these will be pushed to our own GitHub repository. So this will not obviously make the changes in the original repository. And now by using this, by forking and we make any changes, now we can make a pull request also to the original owner of this repository. So we can see if there is a public repository. So here we have the pull request. So these are different users that made this pull request to the owner of this repository to make some changes to any file. And this tells on which branch the new commit needs to be made. The new commit can be merged from this to this. So this shows everything about the changes, all the commits. So all the big public repositories have this pull request. So owner can accept any of these. We can make our own pull request to public repository, which branch we want to make the change to. And after forking, we made some changes. So we see that these were made many years ago, but we make these changes on a local machine and we push that here. So this is now we have another command which is called rebase. So rebasing is an alternative to the merge function that we have. So while using merge, we make a lot of new commits, merge commits. So that creates a lot of new commits. For example, if we are working on a feature branch and we are working, but master branch gets updated uh, a lot of times every day, and we want a feature branch to be up to date to the master branch. So then we merge the master branch into feature branch. So that creates merge commits every time. So there are a lot of commits. So rebasing, what rebasing does is it can uh, change the position and structure of our commits. It can change the history of our commits. So this structure gets changed. We rewrite the history of commits by using rebase instead of merge. So here we create a new folder and initialize the Git repository. So we are on the master branch and we make a new file and we add and commit that, and then we make some modify that file and commit again, and then we switch to a new file. Again we add and commit that, then we make some change and commit again, and now we switch to master. from the this feed branch, and then again we make some changes in the master branch to that file. So till now we have these three logs. First one goes on master, then this feed, then master again. So now we want this master branch to be updated on this new feed branch. So we can switch to that and merge a master on that. So for example, now this creates these two new logs, these two new commits, one for this and then one for merging branch. So when we merge here, so this opens up in our code editor. So this creates another commit. For example, we make another change and then we go into the feed and merge again. We see two more commits. So this creates a lot of commits. So these can be arranged in a more structured manner by using rebasing.